Still talking about exponential growth and decay, right? Growth and decay. We've talked about that the last couple times. So now we have a couple formulas for growth and decay. Very similar formulas, very similar formulas. In fact, what's the only difference between growth and decay formula? What is the difference between them? That's the picture, right? One's going up, one's going down. What's the difference between the formulas? One has a plus inside, one has a minus inside, right? Growth has a plus, that makes sense. Minus has a negative or a minus, that makes sense, right? Okay. We're going to be using these guys today a lot to come up with, to answer questions, okay? So first thing, we have some letters here, A. A is always, they both have an A, right? A is the starting value. Where do we start? Initial value, initial amount. If it's money, it's amount. If it's a value, it's whatever it is, okay? So it's what we start with. R is the rate. If it's growth, it's an increase. If it's decay, it's a decrease. It's always going to be a percent. Problem is calculators don't like percents. Calculators hate percents. The only reason we use percents is because people like to look at percents, right? Like if I go to a store, you don't have to write this down, but it is important. If I go to a store and I'm looking at something to buy, anything, clothes, electronics, whatever, and it's 25% off, right? That's what we see, right? But when they calculate how much it actually is, you're not using 25%, you're changing that to a decimal. So how do we write 25% as a decimal? 0.25, right? There's two ways to do it. First thing you can do is just move the decimal, right? If there is no decimal, if a number doesn't have a decimal, it's at the end. You can just move it 2 spaces, just like that. That's the easy way, right? Another way is just divide it by 100. Go to your calculator and go percent divided by 100, and you'll get a decimal. That works too, okay? Decimals are the way we calculate things. Your calculators love decimals. They hate percents. Percents are the only reason why, like if I gave you a test and I gave it back to you and it had 80% on it, you know, okay, 80% means a low B. If I said 0.8, you'd be like, what does that mean? 0.8, 0.8 on a test, right? So we change it to percents because people like percents, but they're not really helpful in terms of calculating things because their calculator hates percent. Ever go to a store and try to figure out, okay, if this is $55, if this thing is $55 and it's 25% off, how much is it going to be at the register, right? And you go to your calculator, where's the percents? There's no percents because calculators hate percents, okay? So we change it to a decimal. You take the number, multiply it times the decimal, and that's how much percent off, right? So if it's $55, the thing you're buying, you multiply it times 0.25, and that's how much off you get. Right? Okay, so that's the big thing, converting from percent to a decimal. It's not hard, but you just got to remember to do it. Okay, and then the last thing is x. X is the variable up at the top. Time. Whatever time is. Sometimes it's years, sometimes it's minutes, sometimes it's seconds, sometimes it's decades, right? Interval of time, that's all it means. Okay, those are the guys we're going to use. All right, so things that grow exponentially. One of the things that grows exponentially or decays exponentially is population, right? 40 years ago, Fresno had 100,000 people, maybe that. Maybe a little bit more, maybe a little bit less. Today, Fresno has almost 600,000 people that live in Fresno. Population's grown, right? Some cities get bigger, some cities get smaller, okay? This town has a population of 14,000. It grows at 5%. Every year, grows 5%. What will be the population? What will be the population? How many people will there be in 14 years? round to the nearest whole number. Okay? So is this growth or is this decay? Growth, right? It's getting bigger, right? It's getting bigger. So for growth, we use this guy right here. Okay? So let me write it down. Growth y equals a 1 plus r to the x power. Okay? Some of this stuff we know, right? A is initial amount, starting number. What is the starting number of people for this city or for this town? 14,000, right? It says right now it has 14,000 people. 1 plus. R is the rate. What is the rate of increase? 5%, right? We have to change it to a decimal. Okay, so even though 5%, even though R is 5%, we can't write it like that. So what is 5% as a decimal? 0.05. Good. Easy way, move the decimal 2 places to the left. If you can't remember that way, divide it by 100. And you got your percent. Or decimal, sorry. And then years. It says 14 years, right? Time is in years. We have to figure out what y is. Y is the population. So we go to our calculators. The Desmos calculator makes it easy because you can literally put all of this in at once. If you don't have that, if your basic calculator on your iPhone or your Android, you have to do it by pieces. You have to do this, and then this, and then this. But luckily, the Desmos, the one we've been using, is nice because and same thing with Delta Math. Delta Math calculator the same way. We can put it in exactly the way it is. 14,000 parentheses 1 plus 14,000 parentheses 1 plus 0.05 parentheses to the 14 power. Okay. And then we get this number here. Well, it's got a decimals. So we're going to round it. It says round it to the nearest whole number, the nearest whole number. Everything to the left of the decimal is a whole number. Everything to the right is a decimal. The last whole number is the 9 in front of the decimal. So to see if we have to round up, we look behind it, right? 0. 0 says stay where you're at. 0 small. So we're going to stay at 27,719. People. Okay. That's how many will be there in 14 years. Almost double. Okay. Number 2, cars. Cars are not investments. Cars are things that we buy or lease to get us from point A to point B, right? You don't buy a car because it's going to be worth more money in 10 years. You buy a house because of that, right? Houses, property goes up in value, right? Cars don't. Cars lose value like immediately. Like soon as you drive it off the lot, the car is no longer brand new. It's a used car, even if you bought it that same day. So that's why places have like 7-day periods. Like if you go to a car lot and buy a car, they give you 7 days. They're like, if 7 days, if you don't want the car, bring it back for 7 days, and within 7 days, we'll give you your money back. If you bring it back on the 8th day, we'll buy it back, but it's no longer a new car. We're going to give you the used price, right? And the used price is a lot lower. Okay, so what's what we call depreciates. It depreciates. Anything that loses value depreciates. Okay, so a new car is purchased for $20,800. That's how much this car, whatever car it is, brand new. The value of the car depreciates. Almost every car depreciates. The only cars that gain value are like if there's only one of them. Like if they don't make it anymore and there's one car like that or two cars like that, then that car will go up in value because it's rare. But most cars on the road lose value because they're making new cars every day. Every day they're making new cars. Why am I going to pay you top dollar? I can just go buy a new one for top dollar. Okay? So this car depreciates at 10.75% every year. What will the value be to the nearest cent after 13 years? So after 13 years you want to sell it? What would the value be? How much could you sell it for? Okay? Well, depreciates. Depreciates. That's decay, right? So this one is decay. So we're going to use y equals a 1 minus r x power. Okay. Initial amount. How much did they purchase it for? 20,800. 1 minus r. R is 10.75. We got to change it to a decimal though. Even though it already has a decimal, we have to change it to a decimal without a percent. So it's going to be 0.1075. That's the formula or the equation I'm going to use. X is years because it talks about years. Per year, year. Okay. So now I'm going to plug in 13 for X. $20,800 times 1 minus 13 years, was it? 13 years, yeah. Okay. $4,742 and some decimals. Okay. So what number do we stop at? Well, they'll always tell you. So this one, the nearest cent. This one, we need to round to the nearest cent. Oops. So what number, once I get this up here, is in the cents position? So there's two numbers in the cents, 0 and 9, right? 0 and 9. 0 is in the tenths, right? It's tenths, 9. So 9 would be in the cents. This guy right here, the ninths, the 9 is in the position right here. Okay? Right behind it is a 5. So am I going to round up or am I going to stay at 9? Round up, right? So now that the decimal doesn't, or the cents isn't 9 cents, it's 10 cents. So $4,742.10. 4,700. I already forgot. Let's see. $42.10. That's how much it's worth. Okay. It's lost value. It's lost a lot of value. That's what happens. Okay. All right. So let's go to the number 3 on the back. An element. An element is like the things in chemistry. The elemental table, oxygen, hydrogen, helium, all of those things. Elements are anything that is in this world, on this planet, is an element. Okay? So some element has a mass of 210 grams. Okay? It's decaying 8.3% per minute. So it's decaying pretty fast. 8.3% every minute it's losing. How much of the element is still left after 15 minutes to the nearest tenth of a gram? So I want you to do this one on your own. Try to do this one on your own. Figure out how much is left. Make sure you round to the right number, to the tenth of a gram. Tenth of a gram. So we get 57.2478696.2. Okay, so we're not going to write all of those numbers. They just want, this problem here wants us to round to the nearest tenth. Nearest tenth. Well, the tenth is the guy right behind the decimal. So the right of the decimal is the tenth. So in this case, it's the 2 right behind the decimal. The guy behind it is a 4. So does the 4 say to stay at 2 or go up to 3? What does 4 tell us to do? Round up or stay? Stay, yeah, stay. 4 is the highest number where we stay. Anything bigger than 4, 5, 6, 7, 8, 9, we round up. So the 4 behind it says stay. So 57.2. 57.2. So there would be left 57.2 grams. Okay. All right. Okay, so those are the plug and play ones. Plug and play means here's the formula, plug it in, tell me what you get. Okay, so now they're going to change it a little bit. Now for number 4, they're saying, hey, you don't need to plug and play. They're saying, first of all, here's the formula. We already gave you the formula. It's right there. Okay? First thing you have to do is tell me, is it growth or decay? And then once you tell me that, tell me the rate, tell me R, rate of increase or decrease. So we have to say, after all is said and done, is this rate, is this growth or decay? And what is R? So when is something growth or decay? When is something growth or decay? How do we know? Right? We said the picture, right? Arrows going up. If it's going up, it's growth. If it's going down, it's decay, right? What's another way of telling if it's growth or decay? What's another way of saying it? Because we've done this before. Is it growth or is it decay? And then you had to tell whether it was growth or decay. How did we do that? Right? What did we look at? We looked at the part inside the parentheses, right? Right? We looked at this guy right here, B. Right? We did this. We've done this before. We did this for these guys last time, last time, right? Right? And you guys were like, oh, growth, decay. It's the same thing. So the one we're looking at right now, which one would it fit, growth or decay? Decay, right? Decay because it's between 0 and 1. Okay, so it's decay. That's the first thing. So we would say decay. Oops. Okay, that's the first thing. The second thing is, what is R? Well, they skipped a step, right? What they did was, how did they get 0.75 in the parentheses? This is what they did. They did this part right here. 1 minus that guy. 1 minus this guy. 1 plus this guy, right? So we got to figure out what number this is. So essentially what we're doing is we're trying to figure out what number is this. So what they're saying is that. We know it's minus because we said it's decay, right? So that's why I put a minus in front of the question mark. What number would go there to make that number? To make these guys the same, what number would have to go in there? 0.75, right? Yeah, 0.75. 1 minus, so would 1 minus 0.75 make that? 1.75 would 1 minus, so 1 minus what? So in other words, what I'm asking is, 1 minus what is going to be 0.75. 0.75? Or what? So one, let's see. Let's see. So 1 minus, we'll try all of those. It's easy to try, right? 1 point, what was it? 1.75? Close, right? We need it to be plus. What was the other one? So just 75. 1 minus 75? Still negative. We don't want a negative, right? We want a positive number. What number would I plug in there? Let's try 0.25. 1 minus 0.25. There it is right there. That number would give us what we want. So 0.25. So this guy right here is 0.25. What would the rate be? Percent-wise, what would the percent rate be? 25%. Because if it was 25%, you would say, oh, I would put 0.25 in there. Because you'd move the decimal and then you do that. So it's kind of going backwards. It's going backwards. Okay, so we know it's decay, and I know the rate is 25%. It's a rate of decrease because it's decay, and it's 25%. All right. Okay, so try number 5 now. Try number 5. Is it growth or decay, and what's the rate of increase or decrease? I'll give you a minute or so to do that, and then we'll talk about it. All right, so is this growth or decay? Is this one going to be growth or decay? Growth, because the number inside the parentheses, b, is bigger than 1, right? It's like one of these guys. Right? It's be bigger than 1. So it's growth. Okay, we know it's growth. Okay. Now, so it's plus, right? So 1 whole plus what number would give me 1.362? Yeah, 0.362, right? So because we know that, what would the percent be? 36.2% increase. Okay. All right. Okay, last 2 problems. We got 2 left, but these are the thinkers. They're not hard, they're just thinkers. You have to think. Okay? A lot of people don't like to think. Well, if you don't like to think, it's going to be tough. But if you don't mind thinking, they're not bad. Okay? Thinking means, when I say thinking, I mean not knowing what the next step is going to be. You got to think what's the next step going to be. Not everything is written down. Okay, so we have an element, another element, X. It's radioactive isotope, such that every 12 years, its mass decreases by half. So every 12 years, it loses half of its mass, half of what it is. Okay? So it's slowly decreasing. Given the initial mass of the sample is 900 grams, how much of the element would remain after 6 years to the nearest whole number? So first thing to do is to underline, circle, highlight the important stuff. So let's go through this, because I don't think we haven't done too many of these problems before. So element X is a radioactive isotope. Is that important stuff in terms of solving the problem? No. Such that every 12 years, its mass decreases by half. That is important. Every 12 years, its mass decreases by half. That is important. Given that the initial, I've seen that word before, initial is 900 grams. How much would be remaining after 6 years? So all of that stuff I underlined, circled. If you have a highlighter, you can highlight it. That's the stuff that's important for solving the problem. Everything I didn't is not necessarily that important. So this paragraph, or however many 3 sentences it is, 2 sentences, not all of it's important. Going through and analyzing it, okay? Okay, so is it growth or decay? First thing is growth or decay. Is this going to be exponential growth or exponential decay? Is it getting bigger or is it getting smaller? It's decaying, right? It's getting smaller. So the formula we're going to use is the one we've been using before. Okay, so let me fill in that formula. Y equals, what is the initial amount? 900. So we're going to put 900, good. 1 minus, do we know what the rate is? That's half every 12 years, right? We don't know what it is every year, though. So we don't know what R is. We don't know what R is. If I had R, I could just plug in 6 and it'd be done with it. But I don't have R. So I need to find R first. So what am I going to do to solve that? Well, first thing I'm going to do is I'm going to make a table to show exactly what I know. X. X is the time. I know, and Y is grams, right? Y is the mass. So I know that it says 900, right? At what time, at what year is it going to be 900 grams? Yeah, because that's initial, right? So I know at 0 years, it's going to be 900 grams. And then it says 12 years, it decreases by half. So in 12 years, it would be 12, right? How much mass would it be? Yep, 450, right? And then in another 12 years, it would lose half of its mass again. And I could keep going like that, but I'll stop right there. In 36 years, it would be half. In 48 years, it would be half of that, right? What they're asking is when this number is 6, what is that number going to be? That's what they're asking. Okay? Well, to do that, I need R. I don't have R. Right? I know every 12 years, it decreases by half. So what I'm going to do is, all of these are solutions. All of these right here are solutions. I'm going to plug in one of my solutions that I know to find R. I already used this one. That's why I put 900. So I'm going to use this one right here. For X, I'm going to plug in 12. For Y, I'm going to plug in 450. Because these are solutions over here. If they're on the table, they're solutions. And solutions say they should work. So 450, 900, 1 minus R. I don't know R. I'm trying to solve for R. But I know this guy is 12. Okay. So let's look at this guy here. Focus on this guy here. How do I solve that guy for R, right? How do I solve it? In other words, right? Remember we did this, and then we solved for R. We solved for whatever letter. How would we do this guy here? Well, normally we'd start inside the parentheses, right? We'd start inside the parentheses. Can I subtract 1 minus R and get a number? No, I don't know what R is. So if I can't subtract, I also can't do a power. Because a power means you know what number it is, right? How do I know what number to multiply by itself 12 times if I don't even know the number? So I can't do parentheses, I can't do exponents. What else is left over here? What else is left besides parentheses and exponents? So distribute. That's a good question. That's a good suggestion. Can I distribute the 900? The answer is no, you can't. Why can I not distribute the 900? Because it has a power, right? The only time I can do that is when the power is one whole, and it's not one whole. But I like that idea, because what is distributive property? Which operation is it? Add, subtract, multiply, or divide? Multiply. So what that told me was I'm going to multiply this guy. This guy is being multiplied times all of this, right? Well, instead of multiplying it, because I can't do it, what's the opposite? I can divide both sides by 900. If I do that, this becomes a 1, because 900 divided by 900 makes one whole. And I'm left with this. Okay, so what is 450 divided by 900? It's a decimal, but it's a decimal you'll recognize. 0.5, yeah. 1/2. Okay. So now I have to deal with the parentheses that I couldn't deal with before, right? So what do I do? Well, like I said, if this power up here was a 1, I wouldn't have to worry about this. So I need to get rid of this power. How do I undo a 12th power? By a root, right? A root, right? So what I'm going to do here is I'm going to take the root of this. Which root would cancel out 12 power? 12th root, right? Because isn't it a fraction? 12 is the power, 12 is the root, 12 over 12 is just 1, right? That's why it's the 12th root. Well, whatever I do to one side, I have to do to the other. So this guy is going to become just 1 minus r. Because the root is no longer there. The root and the power cancel each other out. And then I go to my calculator and ask it this question here. This question my calculator can do. I'll show you. This button with the root and the n, you hit that button, and then it asks you what power or what root do you want? I want 12. What number goes on the inside? 0.5. So it's going to break down 0.5 and find groups of 10. Or sorry, 12. It's going to find groups of 12. Something I can't do by hand. There it is right there. So we're not going to write all of those numbers, but we're going to write at least 3 of them. We're going to write at least 3 of them. You should always go at least 3. Unless they tell you to do differently, you should go at least 3. So I'm going to go 0.94. Since the behind a 3 is an 8, I'm going to go 0.944. 0.944. How do I get r by itself? What do I got to do? So I want to get rid of the 1, right? Because I want to get r by itself. So 1 is positive or negative? It's positive. So I need to subtract 1 whole from both sides. So 0.944 minus 1 whole. Minus 1 whole, I get a negative decimal. Negative 0.056. Negative 0.056. I'm going to write that down. But R is negative. How do I make R positive? What do I need to do to make R positive? It's negative 1R. How do I make R positive? Divide by negative 1. If you just want to change a sign, divide by negative 1. That makes it positive R and positive 0.50 or 0.056. So now I know what R is. Now I can plug in 6 where I originally wanted to. Plug in 6 up there because I know what R is now. So then you go to your calculator and ask your calculator for the final answer, and you got it. 900 1 minus 0.056 to the 6th power. There's your answer. 636.90473115. But we don't need to write down all of those numbers. We just need to write down what they want us to. In the question, it says round to the nearest whole number. Whole numbers are everything to the left of the decimal. So the whole numbers there are 636. So am I going to stay at 636 or am I going to round up to 637? I'm going to round up because the number right behind the decimal is a 9. That means round up. So 637. 637. Grams. So that's the number that would go right there. I always do a does it make sense check. Does it make sense doesn't really involve calculations. It just doesn't make sense. So if I were to put 637 in the table, would that follow a pattern? Would that make sense? If I were to put this number right here, would that fit with everything? I'm not looking for exact. I'm just looking for does it fit? Yeah, because they're going down, right? So if I go down 6, I'm going to get a little smaller. If I go down 12, I'm going to get a little bit smaller, a little bit smaller. It fits. It fits. If this number here, I got like 1,000 something, then I know I did it wrong because it's supposed to be going down. Or if I got this number was like 100 and something, 130, I know I did something wrong because it should be between these two numbers. It should be between 900 and 450. Okay. All right. All right. Last one. Last one and we'll be done. Money. Now we're talking about money. Something everyone loves. Money. Investing money. Investing money is something very popular because it makes money. Invest in stocks, invest in mutual funds, invest in whatever, real estate, whatever you want to invest in, right? Because if you put in a certain amount, when you come back, there's more money in there, right? A lot of your parents probably are investing money for you. When you're done with high school, if you want to go to college or whatever your plans are, they probably have some money set away like my parents did. My parents invested early so that when I went to college, it would be paid for. And my college was paid for, so I didn't have to take out any loans, which was nice. Okay? So that's one way people invest, right? So this person invested $790 into an account. It's growing at a rate allowing the money to double every 13 years. So every 13 years, it doubles, right? They're not putting money in. They're leaving. Whoever this person is, it's not like they're putting money in every year. They're not. They just put $730 into an account and then forgot about it. 13 years later, it doubled. 13 years after that, it doubled. So for doing nothing, it's doubling. Okay? So 13 years seems like a long time, but did you do anything in that 13 years that would make no, you're not doing it. It's just getting bigger for no reason. Well, there is a reason, but right? So people say, well, 13 years, it's going to double. That's not a lot. You didn't do anything though. You didn't do anything. It's just sitting in an account and it's getting bigger. Okay. Okay. So, how much money would be in the account after 30 years? This is what a lot of people do. When you start working, you plan for retirement because you don't want to have to work when you're old unless you want to, unless people like it. But if you don't want to, you plan for retirement. 30 years is usually when people retire. Have some money in there, okay? So that you don't have to work. You don't have to do that stuff. If you want to, you can, but you don't have to. How much money would be in the account after 30 years? Okay, so I'm going to start to underline, highlight some things. They invested $790. It's doubling every 13 years, times 2 every 13 years. How much money is in the account after 30 years to the nearest dollar? Well, it's doubling. It's getting bigger, right? So that's growth. So we say y equals, what's the initial amount? 790. 1 plus, we don't know what r is. Again, we don't know what r is. We know it doubles every 13 years, but we don't know what the rate is. X. Again, I can't plug in 30 unless I have r, so I need r. Okay, so let's write down what I know. Let's write down what I know on a table. I know at initial, there's $790 in the account. I know that it's going to double in 13 years. So in 13 years, that number, it won't be 790. It's going to be 790 times 2, which is 1,580, I believe. And then in another 13 years, it's going to double again. So that would be $3,160 now you have in an account. So for doing nothing in 26 years, it went up over $2,000, almost $2,500. The question says, okay, when it's 30 years, how much money is going to be sitting there in the bank or the account, whatever it is? Okay, so again, we don't have R, so I can't plug in 30. So I got to find R first. Okay, so let me find R. So to find R, I've already used this first one here, 790. I'm going to use this guy right here, the next one now. 13 for X, 1,580 for Y. So 1,580 equals 790, 1 plus R to the 13th power. Okay. I can't add R and 1. Can't do it. Can't do 13th power if I can't add them. Can't distribute, right? So what I got to do is divide. I'm going to divide both sides by 790. So when I divide both sides by 790, I get 1 over to the right. What do I get to the left? 2 whole. Okay. Want to get rid of the power. So, got to take a root. What root do I take? The 13th root. That gets rid of the power. And then what number times itself 13 times is going to make 2? I don't know that off the top of my head, so I'm going to use my calculator. $1.054766076. It doesn't stop there, it's just my calculator stopped there. So always go at least 3 spaces unless they tell you not to. So I'm going to go 1.054. I'm going to round up to 5. So 1.055. 1.055. Okay. Still got to get R by itself. So I'm going to subtract 1 from both sides, 1 whole from both sides. When I subtract 1 whole, I'm just left with the decimal. So now I can take this number and plug it in. To the 30th power now. And then I got to round to the nearest dollar. I'm going to round to the nearest dollar. So I get 790 times 1 plus 0.055 to the 30th power. Okay, so $3,937.32. Well, 32 cents, does that mean round up or stay where I'm at? If it's 32 cents, do I go up to the next dollar or do I stay at where I'm at? Stay. $3,937. $3,937. Again, check to see if that makes sense. Yeah, that makes sense. It's a little bit bigger. It's 4 years later, almost $4,000. Okay. Here's the question. Last thing I'm going to ask you. My last class did the same problem, and they got this. $3,945. They got that as an answer. Why would they get a different answer? Because this is a question I have. I always get this question. And on test day, there's going to be a difference. Why? So not why. I always get this question. Which one is right? My answer is this is right. If I see this, if you get different answers than me, and I look over here and it's exactly the same, it's okay. You can be off a little bit. You can be off a little bit if this is different or as if this is the same. Now, if you got different numbers in here than I did, then you did something wrong. But sometimes what happens is you round differently. How many times did we round here? We rounded once, twice. Sometimes people round wrong. Sometimes they round differently. When you round differently, it's like a snowball. It creates a different answer. Now, the answers aren't that far off. You're talking about $8. We're talking about almost $4,000, and we're $8 off. Is that a lot of money when you're talking about $4,000? No, it's not a lot of money, right? So I would give credit to both of them as long as your work makes sense. So when I get, because the answer key, you'll put this answer in, and the answer key will be like $3,940. And you'll be like, Mr. Flores, I did it wrong. No, you didn't. You just rounded differently, right? It happens. As long as this work is okay, you're okay. You can be off a little bit. You can be off a little bit. Okay? When you round, things like that happen. Things like that happen. Okay? Right? So Delta Math might mark you wrong, but you're not wrong. That's why I go in on tests and quizzes. I go in afterwards and double check it. Because sometimes Delta Math doesn't like the way you rounded when you rounded okay. So that's why I go in and double check it.